In Maths Problem 1, we have two different functions in Part A and Part B that we want to take the derivative of. Again, the key here is going to be distinguishing when we have exponential functions and when we have power functions. So an exponential is anytime the variable is the exponent. A power function is anytime the variable is the base. So in Part A, to find f prime of x, or the derivative of x, first we start off by taking the derivative of 4e to the x. So 4 is just a constant multiple, so nothing happens to that. So we just need to worry about taking the derivative of e to the x. With the property we have established, that's just e to the x. Then we have the derivative of 8x squared. So now we're back to a power function. So using that rule for the power function, this will become 16x. And again, another power function, plus 7, and then minus our constant of 14. The derivative of that is just going to be 0. So our derivative is just 4e to the x plus 16x plus 7. In Part B, we take a similar approach, just term by term differentiating this. We'll start with this power function, x to the 7th. So that will become 7x to the 6th minus the derivative of another power function. So 5x to the 4th plus the derivative of e cubed. So this is one of those types of problems that math textbooks and math teachers love to throw in there to try to trip people up and confuse them. In this case, e to the 3rd is neither a power function nor an exponential function. The reason is because there's no variable here. E is a constant, 3 is a constant, so whatever e cubed is still just a constant. So the derivative of that is just going to be 0. So minus the derivative of x, which is 1, plus the derivative of e to the x, which is e to the x.